In this video, I'm going to use Power BI Desktop to populate a single table from 32 data sources using data in a GitHub repository, which is the Power BI Party Pack. There's a file named NFL Teams CSV, and that has 32 rows of data, and it has a URL to each team roster. The key to this demo is that all 32 teams have a page with a table with the active roster that has the exact same schema. You've seen the Patriots roster. Let's look at the Giants roster. If I look at the Cowboys roster, it has more than one table, but the first table is always the one of the active players. The main data file in this demo, NFL Teams CSV, is available at https://github.com/criticalpath trading/Power BI Party Pack. Because I'm going to be pulling data from 32 different public websites, privacy is an issue. I'm going to set the project privacy level to ignore so I don't get prompted the first time I try to access one of these websites. Next, I right-click on the raw button and choose Copy Link Address. The raw button is what gives you a direct link to files in GitHub. I'll use the getDataWeb command to retrieve the CSV file and basically build a table in my data model that has the teams, and each row has the URL to a roster. I add a step to use first row as headers. I change the name of the query to teams, which then becomes the name of the table that I've added to my data model. Now's when the fun starts. We'll grab one of these URLs, we'll call getDataWeb, and we'll put in the roster. It pulls up the navigator, and I might see several tables, but table 0 will always be the right one because it's always going to be the first table inside there. So now what I'm going to do is I'm going to change the name of this query to getPlayers. And now that I've done that, let's just go ahead and run the query and see what basically gets dumped out in the data model. I have a getPlayers table, and no matter which of the 32 roster URLs I use, the table schema will always be the same. Now here comes the tricky part where we take the getPlayers query and turn it into a query function. I go to the advanced editor window. I convert the query into a query function by adding some space at the top, adding a parameter list, open, close, paren, and then adding the arrow operator. Our query function needs a single parameter, which is going to be roster URL. And now that I've passed the parameter, I can get rid of the hard-coded URL to the Patriots website inside there and replace it with my query parameter. Once I've created my query function, I can test it just by taking URLs, put it inside there, clicking invoke, and it gives me a return data set. Let's try it with the Giants as well. I'll go ahead, once again, click Get Players, invoke it. Okay, but it's not these manual invocations that really give value. The real value is, let's go back to teams. And remember I have that roster URL column. Now, before I go ahead and pull data, I'm going to filter the data. So when I start testing my work, I'm only pulling 4 teams instead of 32. So now what we're going to do is we're going to call invoke custom function. When you call invoke custom function, you're creating a new column. So you have to give it a column name. I'll call it players. Next, you configure your query function. They're calling it function query, but take your pick. Next, we configure the roster URL parameter. I could type in a value, but I'm going to choose column and choose the roster URL column. Now, when I go ahead and click OK, it takes those 4 URLs and runs 4 different queries. And now what I'm able to do is expand the players column. And it takes 1 row per team and basically expands it to 1 row per player. And what's great is every player row gets the columns from its associated team. So every player row contains its team, division, conference, and city. Okay, time to test things out. Let's go ahead and close the editor window, and let's go ahead and click on refresh. And now what we see is refreshing from the Eagles, the Giants, the Redskins, and the Cowboys. And now I've just downloaded data from 4 sources into a single table right here. Looks pretty good so far. Now, one change I want to make is to my queries. I have a query named teams. It should be called players, but actually I don't want this query to dump data out to the data model. This is just going to be a behind the scenes query. So I'll call this one get teams. I'll then set enable load to false, so it does not produce output. I'll choose the reference command to create a second query named players, whose source is the get teams query. Remember, the get teams enable load is set to false, and enable load for players is set to true. And the idea here is now I can leave get teams alone, and I can do all my data transforms, things like converting columns to numeric values in players. So get teams is the query that does the extraction work, and I'm going to have players as the query dedicated to doing all the transform work. Now that we have 4 teams worth of data, let's do a tiny bit of data modeling. So we'll start by creating a hierarchy on the conference, division, and team. Now I'll create a fast and simple measure, which is going to be player count, just the sum of the rows for each particular player. Now that we've done that, let's go ahead and build something simple on this report page. So I'll add a table, and we'll go ahead and add the team. And in addition to the team, we'll go ahead and add the division and player count. It would be negligent and highly irresponsible of me to add a table without giving it a table style. Next, we'll add a column chart, and we'll use the conference hierarchy as the x-axis. We'll use the player count as the value. And so now I can go into drill down mode. It's not that exciting yet because we only have one division, one conference, and 4 teams. And now we're ready for the grand finale. Let's go ahead and go back into Edit Queries, and we'll revisit the extraction query called Get Teams. Remember the filter I put in place? So I was only downloading 4 teams during my testing? I'll go ahead and remove that filter. And so now I have all 32 teams in that particular table. So when I execute the query this time, it pulls data from 32 different data sources and drops it into a single table. Now I've sped up the video quite a bit, but it just takes a couple seconds to pull data from each of these particular teams. Except for the Atlanta Falcons website, which has the same problem as the team, and that is it performs incredibly well during the season, but absolutely falls apart during the after season and playoffs. But eventually all the sites return their data, and once again the data is just appended into a single output table inside. 49ers take a second too, another old team. But once we have all the data pulled in, what we should see is there's the data. There's all 32 teams inside there. Let's go ahead and try out the hierarchy and drilling up and down the hierarchy, which is a lot more fun now that we have a full 32 teams. And also, let's go ahead and change this over and let's use the new matrix preview. So if I use the matrix preview, you can see that it has some pretty neat capabilities for dealing with hierarchies and dealing with all these NFL players inside. And as cool as the matrix preview is, remember the key point of this video was that query functions allow you to download data from multiple sources and append all rows to a single table.